Alright, hello Algebra 2. Today we're going to talk about Section 7. And in Section 7, we're going back to talking about quadratic functions, right? So instead of setting them equal to 0, they're going to be equal to y. And we're going to talk about how to use completing the square to put them in this form. This form is called Vertex Form. And this is a helpful form because it shows us the transformations of the function. If you remember back to Chapter 2, we talked about what kind of numbers move graphs up and down, left and right, vertical and horizontal stretches and compressions. So we're going to kind of revisit that today, but specifically with parabolas, and we're going to talk about how we take a quadratic function and write it in this form that shows us those transformations. So vertex form is our new vocabulary today, and vertex form looks like this. So each of these functions up here is written in vertex form. Vertex form is y equals a. So a is still the number that tells me if my parabola opens up or down, left or right, tells me if it's skinny or wider. And then I have a quantity, x minus a quantity squared plus k. So in this form, hk is the vertex. So like if h was 3 and k was 2, then I would have x minus 3 quantity squared plus 2. Up in this example up here, y equals x squared minus 4, this is like x minus 0 quantity squared minus 4. So notice that the vertex here is 0, negative 4. It's this point right here. Looking at this case, x minus 2 quantity squared, there's no number we can see added out there, so it's a 0. So my vertex is 2, 0, this point right here. So that is vertex form. X equals h, just as normal, the x-coordinate of the vertex is the axis of symmetry, and a tells me the shape and the direction that it opens. When I start with my quadratic function in this standard form that we're used to seeing, we can complete the square to get my function into vertex form. If a is not 1, then I have to factor that a out before I complete the square, and we'll see what that looks like in our examples. So let's look at this example here. I have y equals x squared minus 2x plus 4. We want to write that in vertex form. So this is not a perfect square. If it was a perfect square, I could just write it as something like that, like factoring it like we did before. But since it's not a perfect square trinomial, we're going to complete the square, okay? So when we complete the square, we're only completing the square on the first two terms. So we're going to take half of b, so 1/2, times negative 2, that's negative 1, and then remember we square that, so that's positive 1, and we're going to add that 1 to x squared minus 2x. But I can't just add it to one side, right? I either have to add it over here to the y, so we could have written this as y plus 1 equals x squared minus 2x plus 1 plus 4. Or I can add and subtract it to the same side. So what I'm doing here is I'm adding 1 to this part and I'm subtracting 1 here. So if I add 1 and subtract 1, I'm really just adding 0, right? So the way that this looks, let me show it to you back here. Remember that the reason we complete the square is that we are turning this side into a perfect square trinomial. So x squared minus 2x plus 1 is x minus 1 quantity squared. And then 4 minus 1 is 3. So my vertex form is x minus 1 quantity squared plus 3. So in this case, my vertex would be positive 1, positive 3. My axis of symmetry would be x equals 1, because that's the x-coordinate of my vertex. And notice that my a value here is 1. So this would be a parabola with a normal width that doesn't have any horizontal or vertical compression. All right, let's take a look at this function, negative 3x squared minus 18x plus 10. So this is our original equation, and I'm going to just kind of write out here how we would simplify this. If this number, if a is not equal to 1, then we have to factor it out or divide everything by that number. So what I'm going to do is I'm going to say, okay, I'm going to factor a negative 3 out of these first two terms. And actually, let me show you another thing here that is sometimes helpful when you're completing the square. If you don't like doing everything on one side of the equation, you can subtract your constant to the other side. So this gives me y minus 10 equals negative 3x squared minus 18x. right? And then I can see a little bit easier the separation. So what I'm going to do before I complete the square is I'm going to factor this -3 out of this side. So I'm going to factor out a -3, and that's going to leave me with x squared plus 6x. Okay, so now I'm going to complete the square on this part. So I do half of 6 because 6 is my b value, which is 3. Then I do 3 squared, which is 9. So look carefully at what I'm going to do here. I'm going to add this 9 inside the parentheses, x squared plus 6x plus 9, right? But notice that this 9 is really being multiplied by -3, right? -3 times 9 is -27. So what I really did is I added a -27 to this side. So what do I have to do on this side? I have to add a -27, or subtract 27, not just 9, because the 9 is multiplied by the -3. So on this side I get y minus 37, and on this side x squared plus 6x plus 9 is x plus 3. Quantity squared, I still have my -3 in front, and then I can just add this 37 over here, so that now this looks like vertex form. So my vertex here would be -3, because remember vertex form is minus, so this is really minus -3, so that -3 is my x value of my vertex. -3, positive 37. Alright, I want you guys to try this one. Notice that a equals 1 here, so this will correspond to like the first example we did. Your answer here is D. And there's the work if you'd like to take a look at that. Notice my vertex will be here, -3, -4. And now I want you to try this one. This is going to correspond to the second example we did. Your answer here is B, and here's the work if you want to look at that. Okay, so what we're going to do in this example is we're going to take a graph and we're going to write the equation of it from the graph. So I'm going to see if I have space to do it here on this screen so you can be looking at the graph the whole time. We're going to identify an important piece of this graph, which is the vertex. Notice the vertex is at +2, -3. So when we write vertex form, it looks like this. A times x minus h quantity squared plus k. My vertex, remember, is h. Okay, so we can at least plug in what we know from the vertex. So x minus 2 quantity squared, and then plus -3 or -3. But the problem here is that I need to find my a value so that I can know which one of these equations actually matches the graph. So what I need to do is find something to plug in for x and y. So I need a point that I can easily tell that this parabola passes through. Well, this one, I can identify this point here as 0, -1. So 0 would be an x, and -1 is a y that my parabola has to pass through. So I'm going to plug in -1 for y. A is still the same. For my x, I'm going to plug in 0. And then I still have -2 quantity squared minus 3. 0 minus 2 is -2. -2 squared is +4. So I have -1 equals 4a minus 3. So I'm going to add 3 to both sides. That gives me 2 equals 4a. And when I divide both sides by 4, 2 over 4 is 1/2 equals a. So now I have my a value. My a value goes in where the a is in vertex form. So I have y equals, instead of a, 1/2 x minus 2 quantity squared minus 3. So this would be my final answer. 1/2 times x minus 2 quantity squared minus 3. So my answer to this question would be B. So now I want you guys to try the same process with this parabola. Alright, your answer here should have been A. And there is the work if you want to see how we got to that point. Okay, so going back to the idea I mentioned at the very beginning of the video of transformations, the vertex form of a parabola helps me to see the transformations. Remember that anything that's inside the function, so whatever is inside the squared, moves my parabola left or right. So h, the h value of the vertex here, moves my parabola left or right. So if I have minus 3, it moves it to the right 3. If I were to have plus 3, it would move it to the left 3, right? Remember that any number outside of the function, so here this is outside of what's being squared, is a vertical translation. So if this was plus 3, it would move it up 3. And if it was minus 10, it would move it down 10. So h and k give me my horizontal and vertical translation, which end up showing me where my vertex is, just like we did in section 2.7. Now remember, my a value tells me if I'm reflecting or dilating. So the a value, if a is positive, right, then my parabola opens up. And if a is negative, my parabola opens down. If the absolute value of a is bigger than 1, so if a is like 3 or negative 3 or 2 or negative 2, it stretches my graph vertically. So it makes it skinnier, if you want to think of it like that. It stretches it up vertically. And if my a value is between 0 and 1, the absolute value, so not taking into account the negative, then it compresses it vertically. So it has the effect of making it look much wider. So for example, if I have y equals 1/2 times x minus 2 quantity squared, this will be a vertical compression. So my parabola will end up looking wider. If I have y equals 2 times x minus 2 quantity squared, then it will end up looking skinnier because it's going to be a vertical stretch. Okay, so let's take a look at how we would graph this equation. So what we're going to do is we're going to put it in vertex form. Of course, we can still do what we did before. We know the equation for the vertex, negative b over 2a, and then we make our table of values. That is still a valid way to graph. All we're doing in this section is showing you another way to do it by putting it into vertex form. So let's start by putting this in vertex form. I'm going to move my 1 to the other side just to get it out of the way for right now. So I have negative 2x squared plus 4x. And then since a is not 1, I need to factor that out. So I'm going to have x squared minus 2x. Then I'm going to take half of b, so half of negative 2, which is negative 1. When I square negative 1, I get positive 1. And I'm going to add that here inside my parentheses. But remember, this 1 is really multiplied by a negative 2. So what I really did was subtract 2. So I need to do that to the other side. That leaves me with y minus 3 equals negative 2 times x minus 1 quantity squared. And when I get the y by itself, I just add that 3 over to this side. Okay, so here I wrote our equation in vertex form up here. So from this equation, we know the vertex is at 1, 3. And we know that our a value is negative 2, so that's going to be a vertical stretch, which will have the effect of making my parabola look narrower. And that negative is going to flip it over the x-axis so that it's going to open downward. And then you just plot a few more points to help you get the graph. So here we would plot the point 1, 3. I know it opens down, so just like we did before, I would just plug in a couple more points. So if I plug in 0, I end up getting 1, and if I plug in 2, I get 1. And we could plug in negative 1, let's say, and we would end up getting negative 4. So if I plugged in 3, I would also get negative 4. And then we graph our parabola just like we did before. Okay, I want you guys to try this one. All right, hopefully you got B. So here you can see the work, if you need to see the work for how to get it into vertex form. The vertex is negative 2, negative 4. I know it opens up because my a value is positive, and I know it's going to be narrower than a regular parabola, than my parent function. Plug in a few more points, plot those points, and then draw your parabola. That is the end of this section, so I will see you in class to practice.